Hey everyone, in this video I'm going to talk about uRPF, which is an acronym for Unicast Reverse Path Forwarding. It has two modes. The first one is strict mode and the second one is loose mode. First we're going to talk about strict mode, so let's get started. I'm going to be using this topology for the strict mode, and I've got two routers here, some servers here, but basically I have two servers. The first thing that I want to remind myself of is, what does a router do when it receives a packet, say R1? Well, what we know is it checks the destination IP address of the packet it receives so that it can forward it, right? Say if there is a matching entry in the routing table, the packet will be forwarded or otherwise dropped. So here's a question for you. When a router, say R1, receives a packet, does it know whether or not the source IP address in the packet is spoofed? Say this R2 sends a packet, and a packet has a source IP address and a destination IP address, right? So does it know that whether or not the source IP address is spoofed? Well, it doesn't. Another question is, how could it know that the sender is really who he claims he is? And you might ask me, why would a router care about this? Okay, I'll show you why. In this topology, I have got R1 here and two web servers behind it, abc.com and xyz.com, with IP addresses 192.168.1.19 and 1.13, and they are both listening on port number 80. First, let me check on this router to, I'll issue show IP route. Show IP route, yes. I've got one static route installed for this network, which is behind R2, and show IP interface brief. Yes. Basically, what I did extra is, I have created one loopback address on R2, and the IP address is 192.168.1.13, which is the same IP address of this server. Why do you think I might have done this? Well, I will spoof my source IP address. As we know, spoofing is simply faking the source IP address, right? We are basically impersonating another computer. Meaning, if I were to send some ICMP messages from this router to, say, to this server abc.com, which IP address do you think R2 will be using as a source IP address? Of course, 12.002, right? Yes. And another question you might ask, why would I spoof my source IP address? Do you remember TCP three-way handshake? You do, right? I want to send, say I'm a bad guy, and I will send a vast number of initial TCP SYN messages from this R2 to this web server without acknowledging the reply SYNs sent from it. So this could certainly crash the server, because the server allocates memory resources for all these SYNs. That's why. Now, I'm going to show you how uRPF strict mode will help prevent this attack. The configuration is very easy. First, let me show you something on router 1. Yes. Show Ceph interface as 1/0. Where is it? It says IP unicast RPF check is disabled. This feature is disabled by default. Please pay attention to this Ceph keyword that I used when I issued the command. Basically, R1 will be using FIB, which is populated by Ceph, to do reverse lookup. So Ceph has to be enabled. I'm going to go into config mode here, and I'm going to go into interface as 1/0, and I'm going to say IP verify unicast source reachable, and I'm going to do a question mark here. I will explain the whole command. We have two options here. The first one is any, and the second one is Rx. The keyword that I'm going to use at the end of the command specifies the mode uRPF operates in. Like it has two modes, like I said before, strict mode and loose mode. Here any refers to loose mode and Rx refers to strict mode. I'll use Rx. That's it. Before I explain this command, well, no, I've explained it. Then I'm going to do something different. It says, hey Mr. R1, please verify that the source IP address of a packet has to be reachable via the same interface the packet arrives on. Say this interface receives a packet, right? And the source IP address of that packet has to be reachable via the same interface, which in this case serial 1/0, right? The packet arrives on. That's it. And we might want to exclude some certain traffic from the uRPF checks. All we need to do is this. I'm going to create an access list. Then I'll explain. I'm going to go ahead and create like access list. No. Access list 119. Deny IP any log input. See, I will use this access list with this command. Basically, we use an access list. This access list will be checked to determine whether the packet should be dropped or forwarded. Say I have some permit statements in this access list. If a packet fails the RPF check, then this access list will be used to determine whether the packet should be dropped or forwarded. But here I'm using deny statement, and I'll be using this access list just for the benefit of seeing some detailed logging information regarding the uRPF failures. Like interface, I'm going to go into interface S1/0 and question mark. Excuse me. Oh, of course not. Yes, question mark. This is the access list. That's it. So, and one more thing, I don't know if you remember, but the default behavior of a logging on ACL is it expresses the messages for 5 minutes and then gives us console messages. And but I want to see them as they happen. So other conft, which is already there, IP access list, logging update, logging question mark, log. Yes, log update. Threshold question mark 1. So the router will not suppress them for 5 minutes. That's it. I think I have enabled. Yes. What I did was with this command I have enabled uRPF on this interface, and this is in strict mode. And I'm using an ACL. Basically, I tagged on an ACL just to see the detailed logging information. That's it. I'm ready. So I'll go to router 2 and I'll send some spoof messages. I'll simply send some traffic sourcing from loopback 1. Was it loopback 1? Show IP interface brief. That's it. So I will send some messages to this server. Ping 192.168.1.19. I'm going to repeat it 3 times, three ICM messages, and timeout will be 0 sourcing loopback 1. Source timeout 0 means it will this router 2 will fill out ICMP packets as fast as it can. I don't want to wait too much. That's it. Did you see what happened? Now I'm gonna go to router 1. This is what I was expecting. See, these are stock messages. It says we are denying this ICMP message which we received on this interface. When I do show IP interface, and if I scroll down to the very bottom, I'll see IP verify source reachable via RX, which means I have enabled unicast's uRPF check on this interface, and it's in strict mode, and 3 packets have been dropped. That's it. So this is strict mode basically, and it's quite easy and it's straightforward. This is the end of uRPF strict mode. Here I'll pause the video and create another topology for loose mode. Now I'm back with a new topology. The original implementation to check the source address was the strict mode. Then it was modified, and this modification is known as loose mode. Basically, it's useful when we are connected to more than one ISP and use asymmetric routing. And the only difference in terms of the command is the keyword at the end. This time I'm going to say, I'll show you. Interface S1/2 IP verify unicast source reachable via any. This is what I'm going to do. And here you see this is the only difference in terms of command. First, and what this command means, sorry, IP verify unicast source reachable by any. This means that the router must be able to reach the source address using any interface on the router. Meaning, as long as we have a route to the source IP address, it's okay to forward it. It doesn't matter which interface the packet comes in on. Okay. Before we configure uRPF, I'll go to ISP2. Let me do show IP interface brief. I've configured only this interface. I'm going to create a loopback address 2 with an IP address 2.2.2.255.255.255.255, and I will do the same thing. See, I have created one loopback address with an IP address 2.2.2.2, and on ISP3 I will do the same thing. Interface loopback 2 with an IP address 2.2.2.2, 255.255.255.255, and I will create another interface loopback address 3, which is 3.3.3.3, 255.255.255.255. That's it. So basically what I did is I have created 2 loopback addresses on ISP3, show IP interface brief, these 2, and on ISP3 1, show IP interface brief. Where is it? I didn't look back 2. No, it was an ISP1, right? Show IP interface brief will show me what I did. Yes, cool. And I will install a static route on ISP1, pointing to, say, ISP2 for this network, IP route 2.2.2.2, 255.255.255.255, and S1/2. That's it. So basically, what I did is I have installed a static route which points to this ISP2, right? The show IP route. That's it. Now I will configure uRPF on both interfaces on ISP1, and this one and this one. int s1/2 IP verify unicast source reachable any. This will be enough, but when I do question mark, we have two other options. The first one is the allow default option. This basically allows the use of the default route in the source verification process. That's it. And please also remember that if the entry points to a null zero, it will be dropped. And we have another option, allow self-ping. If you enable uRPF on an interface and try to ping that interface, it will fail. If you want to be able to ping local interface, we have this option, which I will skip now. That's it. And the other interface is this one, and I will do the same. I'm done. That's it. So I'll go to ISP2, and I will ping 12.0.0.1, and I'll be sourcing it from loopback 2. See, what I'm doing is this: I'm sending a message to this ISP1, and I'm sourcing it from loopback 2, which was 2.2.2.2, and I remember that ISP1 has a default route, excuse me, a static route pointing to this with an exit interface using this interface. Okay, let me do it. That's it. So, but if I do the same thing, I mean, if I were to ping from ISP3, which is this one, what do you think will happen? 13.0.0.1, and I'll source it from where? Loopback 2. Okay, so I will send ICMP messages from ISP3 to ISP1. I will source it from loopback 2. And I have configured uRPF loose mode on both these interfaces. So and the command says that as long as you have a route and entry for this network, the packets should be forwarded, right? But where? Here? I don't know. I'll go to ISP2 and I'll do debug IP ICMP and I'll send a message like this. It will be dropped. These dots indicate that the packets are dropped due to the configuration. I mean uRPF configuration. But if I go to ISP2, did you see what happened? Basically, ISP2 is receiving all of them. When I do show IP interface serial 1/3, did you see what happened here? It says 5 expressed. Expressed means I am receiving some messages. I'm not dropping them because I have an entry for them. In my routing table, I have an entry. So whereas if I were to ping 13.0.0.1 sourcing loopback 3, which was 3.3.3.3, and ISP1 doesn't have a route in his routing table. Now, see, it's dropping the packet. This is the difference. That's it. This is the loose mode, and as you see, uRPF is quite a simple topic, and I hope this video helped you understand uRPF, and you can leave comments if you have any questions. Thanks for watching.